Happy day. This is just a quick run through of some of the problems on the equilibrium packet that may be a little bit confusing. Just kind of go over some of them together here. So the first part of this is just a little bit of Le Chat. Remember, it's just if you add to one side, it's going to shift to the opposite side. If you take something away, put it back. And then remember that only gases and aqueous are going to affect equilibrium, so leave out your solids and your liquids. The other thing to keep in mind is if you see something like this where you've got a sign for delta H, negative means exothermic. And so you really do want to go right in and say plus heat. That way you can treat heat, increase in temperature, for example, as if you were increasing one of your products to figure out which direction it's going to shift. So when you go to do number 6, there are some of this that might be a little bit confusing. If it says that it's negative, negative, positive, negative, I would really go in and add the heat in. So again, if it's negative, then that means that heat would be on your product side. Two of the parts that I would say are a little bit more confusing are probably number 4 and number 5 here. So number 4 says, which system would demonstrate a decrease in the magnitude of the equilibrium constant K when you increase temperature? Okay, so we know that K is equal to the concentration of our products divided by the concentration of our reactants. So what we're basically saying here is we want our K to go down. So if in order for K to go down, that means that our products should be decreasing and our reactants should be increasing, okay? And in order for our products to be decreasing, that means that we're going to be shifting to the left. So that's essentially what you're looking for, is you're checking to see, like, where is it where I would change my temperature? And I'll give you a hint, by the way, that there's more than one answer to this one, okay? All right, and number 5 says, in which system does the addition of a chemical have no effect on the equilibrium? Well, thinking back to what I said earlier about if it's a gas or aqueous, that does matter, but solids and liquids don't. So keeping that in mind, maybe you'll find one that would fall into that. All right, so the next thing I wanted to look at here is number 11. Okay, so, or number 12. We could look at either one of these. So what it asks is the equilibrium constant is given for the reaction. And so, for example, in this problem, they're telling us that Kc is equal to 20.4 at 700 degrees Celsius. So it says, what's the value of Kc for the following reaction? Well, if I take a look here, I can see that what they've done is they reversed it, okay? So they flipped the reaction. So the question is, what happens to K when they flip the reaction? The best thing to do in a situation like this is write your expression. So in this case, I'm going to write what K is normally. So I'm going to say that K for this reaction right here is equal to concentration of SO3 divided by the concentration of SO2 times O2 raised to the half, raised to the 1/2, okay? Now, if I call this K prime, so a new K, right? Just a second K or K2, whatever you want to call it. So then the K for this one, well, if you write this out, what happens? Well, K, or I can call it K prime, a new K, is equal to the concentration of SO2 times the concentration of O2 to the 1/2 divided by the concentration of SO3. Well, what happens? What happened? What's the difference mathematically between these? Are you thinking that it's 1/, it's inverse? So inverse means 1/, which means K prime should specifically be 1/20.4. And so you can actually calculate what that answer would be. So 1 divided by 20.4, and I get 0.049, 0.0490 if I'm using 3 sig figs. And so that's basically how you would do that, okay? So make sure you go ahead and you try those out, see what you would get. But again, this is my original K here. Then figure out how it would look different mathematically, okay? That's how you're going to figure out K. All right, and then let's also take a look at number 20. Okay, so on this one, they are giving us our equation. They're giving us the value of K, and they're saying the reaction has 2.5 molar NOBr at equilibrium. What are the concentrations of NO and Br2 at equilibrium? So these are what we are solving for. So again, what you want to do first is you want to write your expression out. You want to fill in what you know. And in this situation, I already know K and I know my NOBR concentration. So I'm simply looking for NO and BR2, okay? Keep in mind that now we've learned this. If you don't know, you don't have any numbers, what do we use mathematically? Did you say X? And if you're thinking X, that's absolutely right. So if I don't know, I need to use X. So if I'm trying to figure out the two of these, I could call this one X, and if I call that X, I would call this one 2X according to my ratios, okay? Now you're probably thinking, why can't I simply just say, well, if it's 2 NOBRs, then it should be equal and be 2.5 NOs, and then half of that, 1.25 of the BR2 molar. Remember, you don't know exactly what it's going to be at equilibrium. This is not your change step. The only time that stoichiometry works between reactants and products is during the change step. So the only thing that I can do is use X and 2X. So try that out and see if you end up getting the correct answer for that. All right, looking at numbers 22 through 27. Please make sure, A, you're showing your ice boxes. Okay, so none of the problems before needed ice boxes. Now we need ice boxes, okay? And the second thing I want to tell you is have your notes present. That's why we do the class notes. We did 6 different problems so that you could check to see which one is similar to the one that I'm doing. Mimic it. Use that as your example, okay? And so that's supposed to help you. So look back at your notes, have them there, check to see what am I being given, what am I looking for, set up your ice box, and then work it out accordingly. Remember, if initially they tell you something like the flask is initially charged with a particular either reactant or product, then assume, if they don't tell you how much of the other one that there is, assume that it isn't, that you have 0 of it, okay? Again, unless you need it to react, because otherwise then there's no reaction. I don't have any of those like that here, okay? So if you have 2 reactants, and for example, let's say that I told you here that you only put SO2 inside of the flask. There isn't going to be any reaction, everybody, okay? So you need O2 in order to react it. So in a situation like that, you could assume that your O2 it matches. So in this case, it would be a 2-to-1 ratio. So if I said that I had, I don't know, 5 molar of the SO2, then I should have 2.5 molar of the oxygen that's reacting, okay? So otherwise, you don't have a reaction. That doesn't work out, okay? All right, and then looking at, just kind of looking ahead here, this problem is pretty easy. All you need to do is write your expression here and then solve for Q. Compare Q to your value of K, and K is given here. And then the AP questions should be really nice. I want you to read through this and check off. They are some really good AP questions that are in there. Specifically, number 1 is according to the problems that you've done already. All right. I hope this helped. Happy day, everybody.